We live in a world where understanding the sky can save lives. Weather forecasts aren't just predictions, they're lifelines. But have you ever wondered why forecasts sometimes fail us, or how climate shifts impact your daily life right now? Today we'll uncover how meteorology shapes our planet and our future. Welcome to the world of meteorology, where the science of weather doesn't just tell you if it's a beach day, but might actually save your life. Whether it's warning us about hurricanes or figuring out how climate shifts will make your summers feel more like a sauna, meteorology shapes the way we live, work, and even survive. But how does it work? And why is it sometimes, wrong? Let's dive in. Meteorology is basically the science of asking, why is the sky being so dramatic today? It's all about studying the atmosphere and understanding weather patterns, storm systems, and long-term climate trends. It includes everything from cloud formation, nature's Instagram filters, to the interactions between air, water, and land. It's a huge field with several sub-disciplines, including synoptic meteorology, which is weather forecasting. Yep, the part where people on TV try to guess what's going on tomorrow. Dynamic meteorology, which is all about how air moves, explaining everything from gentle breezes to those hurricane winds that flip cars like pancakes. Applied meteorology, which uses weather science in industries like farming, flying planes, and keeping power grids running smoothly. Essentially, meteorology isn't just about figuring out if it's going to rain, it's about keeping society running smoothly. Now let's talk about the rules of the sky. Meteorology relies on some basic principles of atmospheric science that sound like something out of a sci-fi movie, but are actually just physics doing its thing. Laws of thermodynamics explain how heat and energy move through the atmosphere, affecting temperature and pressure. Translation? They're the reason you're sweating 1 second and freezing the next. Fluid dynamics governs how air moves, which is crucial for understanding winds, storms, and why your hair always gets ruined during a breeze. Radiation and heat transfer involves the sun beaming energy to Earth, driving all the atmospheric drama. The balance between incoming and outgoing radiation decides whether you'll need sunscreen or a snow shovel. The hydrological cycle turns water vapor into clouds, clouds into rain, and rain into you cursing at the sky because you forgot an umbrella. These principles guide everything meteorologists do, whether it's predicting a thunderstorm or explaining why hurricanes seem to be getting angrier every year. Meteorologists don't just stare at the sky and hope for the best. They've got some seriously cool tech to help them out. Satellites, which are high-tech spies in space that track cloud cover, storm systems, and temperature changes across the globe. Weather radars detect precipitation and help monitor the intensity of storms, and sometimes ruin your TV signal during bad weather. Weather balloons are sent up with instruments to measure pressure, temperature, and humidity, basically like a Snapchat streak, but with science. Ground stations record local conditions like wind speed and rainfall, kind of like the neighborhood gossip of weather tools. Supercomputers crunch insane amounts of data to simulate weather models, predicting everything from tomorrow's sunshine to next week's storm. It's all about turning raw data into life-saving forecasts, and maybe letting you know if your weekend plans are about to get soaked. Weather models are the brain behind modern meteorology. They're basically math nerds that use equations to simulate how the atmosphere behaves over time. Meteorologists feed these models with data like temperature, pressure, and wind speed, and voila! You get a weather forecast. But here's the catch. No model is perfect. Initial condition errors. A tiny mistake in input data can spiral out of control thanks to the butterfly effect. Resolution issues. Small-scale phenomena like tornadoes can be too complex for models to accurately capture. Uncertainty in long-term predictions. After about 10 days, forecasts start to resemble wild guesses. Why? Because the atmosphere is chaotic. It's basically nature's version of an unpredictable roommate. So, the next time your forecast is wrong, don't blame the meteorologist. Blame chaos theory. When the atmosphere decides to really show off, we get extreme weather. Hurricanes. These form when warm ocean waters above 26.5 degrees Celsius feed a storm system, creating a monster cyclone. Add in the Earth's rotation, the Coriolis effect, and you've got yourself a hurricane. Tornadoes. Tornadoes are the love child of warm, moist air and cold, dry air. When wind shear gets involved, thunderstorms can spawn these spinning nightmares. Blizzards, a combination of freezing air, moisture, and strong winds creates the snowstorm equivalent of Mother Nature slapping you in the face. Extreme weather events are like the blockbuster movies of meteorology, huge, dramatic, and impossible to ignore. El Niño and La Niña are the Earth's moody phases, part of the El Niño Southern Oscillation, or ENSO, climate pattern. El Niño warms the Pacific Ocean's surface, disrupting normal weather patterns. Peru gets floods, Australia gets droughts, and the rest of us get chaos. La Niña, the opposite, with cooler Pacific waters and stronger trade winds. Expect heavier rainfall in places like Southeast Asia. These two patterns are like the world's weather DJs, remixing storms, hurricanes, and global temperature anomalies whenever they feel like it. Meteorology isn't just about deciding if you need an umbrella, it's critical for agriculture. Farmers rely on forecasts to know when to plant, water, and harvest. Disaster management, early warnings for hurricanes and floods save lives and property. Transportation, aviation and shipping depend on accurate weather reports to avoid turbulence and storms. Public health. Predicting heat waves and cold spells prevents weather-related illnesses. In short, meteorology keeps society from spiraling into chaos. Well, most of the time. Meteorology and climate change go hand in hand. Long-term weather records help scientists track trends like rising temperatures, shifting rainfall patterns, and increasing storm intensity. Models also simulate future scenarios, guiding policy decisions on global warming. For example, studying how warmer seas might create stronger hurricanes helps us prepare for what's to come. Meteorologists are essentially detectives, piecing together how human activity is reshaping the planet and how we can adapt. Even with all our advances, meteorology faces hurdles. Prediction accuracy. Sudden weather changes remain tricky to predict. Data gaps. Oceans and polar regions are still under-monitored. Climate complexity. Understanding how global warming impacts extreme weather is an ongoing puzzle. Communicating uncertainty. Making technical forecasts understandable for the public is no small feat, but the future looks bright, or at least partly cloudy. Emerging technologies like AI, high-resolution models, and even crowdsourced data, your smartphone sensors could secretly be helping, are revolutionizing meteorology. I'll leave you to discuss in the comments about how meteorology shapes our planet and our future. Don't forget to subscribe if you haven't already. Take care of yourselves, take care of your loved ones, and I'll catch you soon in another video.